Now that we're capable of graphing quadratic equations, we're actually going to explore it a little bit, meaning not only are we going to graph it, but we're going to be answering questions based on the said graph. So again, a little bit of review. Quadratic function written in the form ax squared plus bx plus c gives me 0, where a, b, and c are just any old number that you can think of. The x-intercepts, when y equals 0, the parabola, they are called roots or solutions to the equation. So again, we want to know what the x value is. In looking at a graph, it's just where the parabola happens to cross the x-axis. So those x values are going to be my roots. So how many roots are possible to obtain from a quadratic equation? Well, the simple answer is 0, 1, or 2. So how do we know whether it's 0, 1, or 2? So again, if this is 0 roots, this means it does not cross the x-axis. So this means if I have a parabola opening up, it's going to come down, it's not going to touch the x-axis, and it's going to go on up. Now, if we had a negative x squared, that means we're opening down, meaning we come up. And again, we're not going to hit the x-axis, and we go down. So those two possible scenarios, whether I have positive x squared or negative x squared value, I don't hit the x-axis, therefore we have no solution. Now, if we have one root, this basically means my graph is going to touch the x-axis and then go back up or down. So if we have a parabola opening up, it's going to come down, it's going to touch the x-axis, and it's going to go back up. So there is one answer because it touches the x-axis right there. So we only have one spot. So, and then we could also say the other direction. If we open up, it comes up, touches the x-axis, and then goes back down. So again, only one spot, there's only one solution. So whether we have a positive x squared touching in one spot or a negative x squared, as long as we hit the x-axis in one spot, we only have one possible root. Now, two roots means it comes down through the x-axis and then back up. So two roots, if it's a positive x squared, it's going to come down through and back up. So again, it crosses in two different spots. It crosses right there and over here. So there we have two roots. And if we have a negative x squared means we come up and then back down. So again, two spots, it crosses the x-axis here and there. So again, those are the possible scenarios. If we have a negative x squared, it comes up and then back down through. Or if we had a positive x squared, it comes down and then back up through. So that would be two roots. So we have to be aware of how many possible answers we could have. So now let's say we have the graph of the equation x squared minus 7x plus 10 here on the left. What is the axis of symmetry? Again, axis of symmetry is the x equals. And basically, it's where we start. In this case, it stops coming down and then going back up. So down here in the bottom here. So this is our axis of symmetry. And we usually draw a dashed line through it. So there's the axis of symmetry. Now, what is the x value? I see I go right 1, 2, 3.5. So 3.5. And then the coordinates of the turning point. Well, turning point is, first of all, the x value, our axis of symmetry, so 3.5. And then the y value, I see I went down 2. So there's our turning point, 3.5, 2. So is this a maximum or a minimum? Again, maximum would be the highest point, minimum would be the lowest point. I see on our graph it is the lowest point, so it's going to be a minimum. How many zeros are there? Well, how many times do I cross the x-axis? In this case, I see I cross it 1, 2 times. So twice. And then what are the solutions? So again, I just need to list the x values of those 2 points. So x equals, I go right to 2. So x equals 2. and x equals, and then I go 1, 2, 3, 4, 5. So those are my solutions, x equals 2 and x equals 5. And again, what are the solutions called? They're called roots. So again, depending on the language used, you will see the roots, or you would see solutions, or you could see zeros. They're all the same thing. Roots, solutions, zeros, same thing. It just depends on what we have. So again, we could solve algebraically, meaning factor. If we can factor a trinomial, remember we can always split it up into two possible parentheses. Again, this is if it's factorable. So first things first, when I multiply this, how do I get x squared? Well, the only possible way is x times x. And then recall, the numbers that I put down have to multiply to 10 and add to the middle term, negative 7. So we're going to list off factors of 10, which is 10 times 1, 5 times 2. So those are the only possible factors I could get for 10. Which of the two looks like I could get to 7? Well, it's going to be 5 and 2. So I look at the setup of the equation. I see we have a positive 10 and a negative 7. So I know when I multiply, the only way I can get a positive is whether it's positive times positive or negative times negative. The middle term is negative, therefore we are going to be using minus and minus. Negative 5 times negative 2 gives me positive 10. Negative 5 and negative 2 makes negative 7. Now what we do is we split these up and set each one equal to 0. So we get x minus 5 gives me 0, and x minus 2 gives me 0. So I solve for x by adding 5, and we get x equals 5. Do the same thing, I add 2 to both sides, and we get x equals 2. So notice that solving algebraically, we end up getting the same answer by just looking at the parabola of a graph where it crosses. So notice it crossed at x equals 2 and x equals 5. Notice we came up with x equals 5 and x equals 2 as solutions by solving algebraically. Same with this one. Now this one, they gave us the equation, but they don't give us the graph. So in order to do the graph, we can either use the axis of symmetry formula, or if they don't give us the space like they do here, I can always plug it into the calculator. Again, f of x equals y equals, it doesn't really matter. It's the same thing. And I plug in negative x squared minus 6x minus 5. So in order to graph it, I could hit the graph button, but it's not going to give me anything but the graph. So I see what it should look like, but it doesn't help me plot the points. So I'm going to go to the table, second graph. And what I want to do is I want to look for the points where my y values end up repeating a little bit. So here I see we got 3 and 3 repeating a little bit, so that tells me I got to go up a little bit. So notice now between the x values of negative 6 and 0, I am now repeating y values, negative 5 back around to negative 5. So this is what I am going to be plotting. So negative 6, negative 5. So left 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Negative 5, 0. Negative 4, 3. So back 4, up 3. Negative 3, 4, back 3, up 4. Negative 2, 3, so back 2, up 3. And notice we're starting to come back down around. Negative 1, 0. And 0, negative 5. So now what we want to do is we want to connect the points as best we can. Again, it's curve. Arrows at the end. And now we can determine the axis of symmetry. So the axis of symmetry is the x value of our turning point. So in the middle, negative 3, 4. We also see that it also happens to be right here at our turning point. Again, dotted line. Shows our axis of symmetry. In this case, it's x equals -3. Turning point, we already have it in the middle on our calculator as well, so -3, 4. We could also count on our graph. We go left 3, up 4, so -3, 4. Do we have a maximum or a minimum? Well, is it the highest point for a maximum or is it the lowest point for a minimum? I see it's the highest point, so we have a maximum. How many zeros are there? Well, again, how many times do I cross the x-axis? Once, twice. What are the solutions? So again, I just list what the x values are. So I go left 1, so x equals -1. And x equals, and then I go left 1, 2, 3, 4, 5. So -5. And what do we call these solutions? Roots. So again, if I were to solve algebraically, I would end up with the same solutions. X equals -1, x equals -5. Now the weird thing about this is we have a negative leading, so it might throw you off a little bit. So instead of saying f of x, we can say 0 equals -x squared minus 6x minus 5. So now what we have to remember when our factoring terms, remember we can always pull off a common factor if need be. Notice all of these are negative. And the other thing about this, because our leading term is negative, we want to get rid of it. So we're going to actually divide everything by that -1. So the common factor comes down off. So 0 equals -1 times, and then I just change the value of everything. So x squared plus 6x plus 5. Now if I can factor this trinomial that's inside the parentheses, we end up breaking it down into 2 parentheses. So the only thing that could give me x squared is x times x. And then the numbers will multiply to 5 and add to 6. So the only things that multiply to 5 is 5 times 1. Now, because both terms are positive, it'd be plus and plus. So we end up with -1 times x plus 5 times x plus 1. So 5 times 1 gives me 5. 5 plus 1 gives me 6. So we were able to factor it. So now what we want to do is, now we have the factored form of our equation, -1 times x plus 5 times x plus 1. I want to know the values of x that give me an answer of 0. So I'm actually going to ignore -1. There's no x involved. So I just split up our parentheses and set each one equal to 0. So x plus 5 gives me 0, and x plus 1 gives me 0. So I'm going to subtract 5. So we get x equals -5. And we subtract 1, and we get x equals -1. So again, notice we came up with the same solutions, -5 and -1, as we did by just reading our graph. So that is solving a quadratic equation where our leading term is negative. We have to factor off -1 and then factor the trinomial that we have left after factoring. Now 3 and 4 tells us to write the equation for each graph below. So first things first, we state what the solutions are. So here we have x equals, and from our origin, 1, 2, 3, 4, we go left 4, so -4, and x equals, we go right 1. So set each thing, so now that we have x equals -4 and x equals 1, remember in the previous video we looked at that I end up making a binomial with the letter and the opposite value of our given answer. So x equals -4 means our binomial would be x plus 4. And we have to multiply it times the other one, so x, and then 1 becomes -1, gives me 0. And we distribute, so we end up with x squared minus x plus 4x minus 4 gives me 0. Combine like terms, x squared plus 3x minus 4 gives me 0. So now that we figured out the equation, I take a look. Do we have a positive leading term where we're opening up, or do we have a negative leading term where we're opening down? In this case, we're opening up, so I am going to leave it as it is, x squared plus 3x minus 4. Now the other one, example 4, I'm going to do the same thing I just did. So first thing, we determine our solutions. X equals, and I see from our origin, we go left 2 spots, so -2, and x equals, and then I go 1, 2, 3 to the right. So x equals 3. So what I have to do now is I have to multiply 2 binomials, and again, the binomials ends up, in this case, being the letter we have with the opposite value of our answer. So -2 becomes +2. And then I multiply by the same thing, x, and then 3 becomes -3 equals 0. We distribute, so we have x squared minus 3x plus 2x minus 6 gives me 0. Combine our like terms, so we have x squared minus x minus 6 gives me 0. So there is the equation that we have to deal with. Now the last thing we have to determine is whether we're opening up or opening down. In this case, we're opening down, so this means my leading term has to be negative. So in our case, we have a positive x squared. So to make it negative, I have to multiply the entire equation times -1. So when I multiply everything by -1, it just changes the sign of what we have. So now we have -x squared plus x plus 6 gives me 0. And if you want to check to make sure, you can always go into our calculator and go to y equals, clear it out, and then plug in our final answer. So we ended up with -x squared plus x plus 6. And if I look at the graph, notice it comes up. We run through -2. We are opening down and running back through +3. So there is our final answer. And again, if you weren't sure, if you went back and you left it as x squared minus x minus 6, and you took a look at the graph, notice it opens down. Therefore, that couldn't possibly be our answer. That's why we multiply by -1. We made our leading term -x squared. So we can continue doing that. This day and the next day is actually pretty much the same thing, graphing and exploring quadratic equations, answering questions based on said graph, creating equations, and coming up with solutions. So that is exploring and coming up with answers based on a quadratic equation and its graph.